Welcome to the Net Podcasts, the first one for 2021. Sayonara 2022. We want to welcome our first guest of the year, Thomas Graf. And the topic today is, broadly speaking, eBPF, something near and dear to Thomas's heart. Thomas, you want to just give listeners a little intro on your background and kind of what you guys do today?
Sure. First of all, thanks a lot for having me. It's a pleasure to talk to all of you. It's been a while. So my name is Thomas. I'm living in Switzerland. I grew up in Switzerland, so I have a Swiss heart. I worked for a lot of American companies in my career, but I never left, or never relocated out of Switzerland, mostly because of the snow and skiing, which we currently have a lot of. My background is in Linux kernel development, so I started out as a Linux kernel engineer working for Red Hat straight out of basically studying, so that was my first real job. Kind of hanging around in networking, security, working on what maybe could have been called like early days of software networking. So I worked on a TCP IP stack, on like routing, quality of service, IP routing, NetFilter, IP tables, and so on, like all of those Linux networking technologies. You will find one or two patches in all of them from me. So I did that for about 10 years, and then went over and switched to Cisco and actually worked together with Kyle for a while. These were the days of OpenStack and Open vSwitch, so I was in the Open vSwitch core team, worked on Open vSwitch. And then kind of while experiencing and kind of following the eBPF wave as it started to appear, I saw that ship just waiting there to be sailed, I guess, and really hopped on and started working on the Cilium project, which I guess we'll talk a little bit about. That's how I've been spending the last 4 or 5 years. And then shortly after, actually founded a company together with Dan Wendland behind Cilium, and to make or to combine the open source project with a powerful company to also make an effort there.
Oh, fantastic! Yeah, can you tell us about the Cilium project? Kind of like what's his background, and maybe like just get us fast forwarded to where it's at today.
Yeah, I think I will give you a quick TLDR, and then we can dive into more details. As I mentioned, I was on the OVS team for a while. I was working as what's called an IC on kind of during the SDN age, developing on various open source technologies projects, and SDN obviously was not remote to me at all, because doing networking in software is what I've done from day one. So initially I didn't even fully get SDN at the very beginning, because that's what I've already been doing, just in a different form. But then we saw what kind of SDN made a clear, significant step for the age of virtualization, but it didn't really change anything meaningfully from evolving away from what I would call a device or machine-based model. So it's still fundamentally about connecting machines with very networking-specific terminology. So to give a concrete example, physical routers became virtual routers, and physical switches became virtual switches. We literally called everything like virtual, right? And in terms of programmability, we were talking about programmable flow tables and so on. With Cilium, we're taking that one significant step further. So we are bringing in eBPF, a more general purpose programmability language for the Linux kernel, and we are ditching the device-centric model to bring it up to a more cloud-native world. So instead of thinking about connecting machines or devices, we're thinking about applications and services, APIs, and so on, and bringing networking to that level. That, in a nutshell, is what Cilium is about.
Oh, cool. Yeah, I guess, Kyle, you had some specific questions. You want to jump into those?
Well, I mean, you can put me on the spot, but no, that's great. No, I love, first of all, I love what Cilium's doing, and I love the whole eBPF angle. And I think one thing that would be interesting to talk about and maybe hear from you as well, Thomas, eBPF is composed of a lot, right? Like there's different places where you can run eBPF programs, whether it's before the Linux networking stack at like XDP, you can run it as TC hooks. And I think it's really, to me, the most interesting part, and I think that Cilium takes advantage of this, and I'd love to hear your take on this, is I like the socket-based stuff that's starting to be exposed and what you can do with that, because to me, as an application developer as well, I think there's some really interesting things you can do with like some of the sock map and the sock hash type of things in there as well. Could you kind of, I know I just talked about a lot there, but
you just brought up the perfect example what I mean with like ditching the device and machine-centric model. If you look at, first of all, maybe to correct or to kind of prior to make my previous point a bit more exact, like I think SDN as it was defined was actually exactly the right step. I think what we're doing right now with Cilium would not have been possible out of the gate from the pre-SDN age. So I think it was actually exactly the right leap size for the industry to actually take it on. But what Kyle mentions here is the ability to do some of what was typically done at the network packet level. Let's say load balancing or DNAT. Why does that have to be done at the network packet level if you can do that before that? So with eBPF, we have the ability to do load balancing at the socket level, at the connect system call level, to translate a service IP or a VIP into the relevant backend IP of the service in the connect system calls. You do this once before even a single network packet is even crafted. And then the entire life cycle of the connection is NAT free. Like you don't do anything to the connection whatsoever. There is no packet manually going on whatsoever. Obviously, this concept is not entirely new. Client-side load balancing has existed for a long time, but it was usually embedded into the application. So what we can offer is the benefits of client-side load balancing without requiring to actually change application code. It's a very common, I think, a great example on how eBPF achieves something in a unique style that is just not possible if you stay at the networking level. But maybe we can talk about
that's the part you were saying, like that's analogous to how SDN sort of decomposed things and said, well, they don't all have to be in the same place. Some can be over here and some can be over here. That's the part that for me that's the most appealing is what you're saying is that we're up to a kind of a scaling issue now with servers, right? Jamming everything through the kernel is clearly not going to work, and now hardware offloading is the next step, and then even sort of DPU and et cetera is going on. That to me is the most interesting thing here, and there's also an interesting analogy too of how we built HFRs, so to speak, really, really huge scale routers and stuff. We took a lot of this stuff, a lot of these concepts are very similar, right? We were doing, offloading on NICs, line cards and routers, but we were also decomposing, the NPU was also becoming a bottleneck. So then we were doing stuff in the ASICs around it, the port processor, ASIC, the more stuff changes, the more that stays the same, right?
Yeah, I think
and that's the interesting thing for me.
Absolutely, I think there's a property of eBPF that I think is unique and actually allows it to bring networking to, let's say, a modern cloud-native world a bit quicker than you would typically expect, and it decouples the typical lag that you will find when either network vendors or an operating system provides the building blocks that are then later used for programmability. Like, let's say, in a NIC, it might be certain functionality that even a smart NIC provides. There are certain building blocks. You don't have general purpose. You can't do everything, right? There's limitations, and the vendor has to bake in some assumptions on what are the future problems to be solved. That exists both on the hardware side, but it actually also exists on the Linux side. The building blocks that the Linux kernel provides, let's say IP tables, routing rules, the networking stack, all the little knobs you have, they have been built with a certain assumption in mind. What are the future problems that the users will solve? And that lag time is anywhere from like 2 to 10 years. If you look at how old the Linux kernel actually is that a user will run, typically many, many years. I've always been on the end of like writing the kernel features that then get used years and years and years later. We even saw that in Open vSwitch. The moment Open vSwitch was merged into the Linux kernel, the data path capability of OpenWhisk, which was limited by the kernel version that you would run. Kind of you had to load a kernel module to get around that. eBPF has a massive advantage there because the runtime itself is on a generic level, which means it gives you the programmability without any assumptions around the building blocks that you're using to do programmability. eBPF itself has very little networking specific elements. There are concepts like a longest prefix match table, for example, to do routing, but there's nothing like a VLAN concept or something like this. There is nothing like a programmable flow table. It's generic. So it means that yes, innovation has to happen at the runtime. So you have like an engine that gives you the programmability, and that engine has certain features based on the kernel version. But within those capabilities, you can innovate freely, and you can meet the current demands of the market right there with whatever kernel version the actual user is running. And that translates nicely into SmartNICs as well. If you look at how eBPF programs are offloaded, the SmartNICs, like if you look at the eBPF offload, it's typically general purpose ARM CPUs that can simply run the eBPF program. So again, you're not really limited by kind of the building blocks that the SmartNIC gives you. You don't need direct access to the SmartNIC vendors to get onto the roadmap early enough. You can leverage the general purpose programmability. That element, I think, besides moving out of the device model, is the strongest overall element of eBPF.
Yeah, that's really cool because it allows you to mix and match workload processing on basically the same form factor, right? The same for you or whatever you can do, depending on the NICs you have, like you're saying, you can mix and match that processing. And where I saw things going kind of in the wrong direction, where people were starting to create purpose-built NICs themselves, where it's kind of like what you were just saying, like things get deployed, like in service providers, these boxes are out there for 6, 7, 8 years, or until they fail. And, they get deployed. You're not going to go run around and pull cards in and out of these things. And there's sort of the mix and match ability the eBPF model gives you is really appealing for me in that regard too. Like it's longevity to the
That's
deployment.
Actually a kind of a side effect of the assumption based on x86 CPUs being very power hungry, and that assumption has changed already significantly with the move over to ARM. Like a general purpose CPU is no longer equal very power hungry. Right? If you're running a really, really large data center and you're deploying hundreds of thousands of very power hungry SmartNICs, like it's not cost effective. So if you know the pre-baked functionality that you need, like the fixed functionality can be more efficient. But I think in particular ARM CPUs are changing this again.
Yeah. The other interesting that's happening too is we're running BPF and some of the new NIC architectures allowing you to run. It's sort of like virtualization. You're running another machine on the NIC, basically, right? You're running an instance of Linux on the NIC. A full instance of Linux, but then again, you can mix and match with the eBPF concepts, to program different ports on that NIC or whatever. And it's interesting too to me that and it was kind of one of the questions I had around the sort of compiler and the portability of the programs from footprint to footprint, so to speak. And is that something you guys have been thinking about? And because I really, that's again another really powerful thing. If you can say, well, suddenly I want to change, that NIC to doing firewall processing, or add firewall processing because I've got a new customer coming in on that port. Being able to do that in a virtual way, without having to go physically touch anything is really powerful.
Yeah, absolutely. And I think the way BPF is shaped and how you typically do BPF networking is not hard to fulfill for SmartNIC vendors. Typically, you have a relatively simple instruction set that is used to program the actual logic and the packet like the protocol parsing. Like pretty straightforward, very similar to what you would also do in something like P4 or a different kind of parsing language. The main difference is that it is in no way, there's no network concepts baked in. Right? There's nothing like a parsed Ethernet header predefined or something like this. So There's no protocol awareness whatsoever in the actual NIC required. And then decoupled from this, you have the actual data structures. So unlike a regular program that you run on your general purpose CPU, BPF strictly separates the actual program logic that runs and the state. Obviously, you also have stack available, but typically any sort of state, such as, for example, a connection tracking table or firewall rule sets, all of that is in BPF maps, like data structures. They're very general purpose and very easy to map to hardware concepts as well. So a SmartNIC can easily implement and represent eBPF maps as well.
Yeah, and I think that one thing is the maps. I feel like if you combine an eBPF program with the maps, and then you use something like console or something like a distributed KV store, you can really do some pretty powerful things, which is kind of like some of the experimenting that we've been doing, in my day job type of situation. But that's a really powerful concept, and that's one of the reasons we really love it, is because it allows you. I mean, the eBPF programs are pretty simple in terms of what they do, and they're I think once you understand how to write them and some of the constraints that the compiler applies to you, it becomes pretty easy to write them, and they're really easy to read as well, I feel like. So I think there's some real advantages from a programmability perspective there too.
Absolutely. I think it's a significant another significant evolution step to, let's say, a typical SDN architecture as we know it. There's an aspect of the control plane being much closer to something like Kubernetes or something completely distributed, right? Like either it's a key value store or you're using Kubernetes CRDs or something like that to distribute state across different nodes. And then based on that, you can synchronize that into maps. But it's for example, drive firewall policies, to drive visibility and so on. It doesn't just go like the control way, there's also the other way around. I think the visibility angle of eBPF is absolutely exciting. So eBPF programs can be simple, but we, for example, have also built an HTTP parser entirely in eBPF. So all of a sudden, you can get layer 7 visibility on with pure Linux kernel view, right? And like no proxy involved, no sidecar, no termination of actual TCP connections. Just transparently, you get like HTTP visibility with an eBPF program, or you can extract and combine metrics, for example, TCP latencies with network views. So you can, for example, measure the latency. How long does it take to actually establish a full TCP handshake, and combine that with the typical flow log? You can combine, and this is, for example, what Cilium does. It will take pod level or application level metadata, such as a pod name, pod labels, and so on, and will allow that context to be embedded into network packets. So anywhere in the network, you will have that context available, both for visibility and security enforcement.
Yeah, that's another really, really interesting feature too. I mean, that's been a part of the heartburn I've had with the Kubernetes, like you mentioned, sidecar mode and things like that for processing. This is like a true bump in the wire model where, again, you can, sort of like we did OpenFlow and IPFix and so on, where you're tracking the flows, and it's very transparent, in that it's a relatively small number of operations that happen on the NIC, like you're saying, before the packet phase. Mm-hmm. And so the kernel doesn't really even know it happened. It's just,
the instrumentation
and the implications for beyond statistics and stuff are really cool. Sorry, go ahead, Brent.
Oh, sorry. No, I totally agree. The instrumentation aspects of it, I think a lot of people think of BPF, think packet filtering. I think, being able to. So I'm wondering, I want to make sure that I still understand kind of the process of eBPF as it gets into the kernel. So let's just say I'm a user. I'm going to write some C code. It's going to compile CLang, LLVM, gets it into bytecode, goes to the kernel, kernel's going to convert to machine, and for the appropriate hardware type. Is that still kind of the general flow there, Thomas?
Yeah, that's general flow. I would say that's for the power users. I would say most users will use eBPF not directly in bytecode or not even C, but they will just use something like Cilium or one of the many other eBPF projects, right? I think.
So that's where I wanted to go.
Okay, yeah, go ahead.
Yeah, no. So that's the kernel side. Like that's the part that generally a potato head like myself is going to be like, do I really need this functionality? Is there a user abstraction I can use? So is that where Cilium? It used to be BCC. Is that where does that come into play? And so it's kind of like these abstractions to get it down into that lower level part.
Yeah, I think you can look at eBPF as a kernel level technology to the most extent. Then it's a perfect tool to work around the difficulty of getting kernel changes into the kernel. It's working around the complication that if you want to do a kernel change, you have to find consensus with the entire community. You need to convince the data center folks running like large scale data centers and the embedded folks running Android, right? It's all the same Linux kernel. They all need to be on board with every single change. It's becoming more and more difficult. And eBPF with the programmability allows you, similar to JavaScript in a standard web browser, allows you to not require a kernel or browser change for every small piece of change that you need. That's the motivation of eBPF. It's meant for as an alternative to extend the kernel. So it's meant for kernel developers. And then on top of that, you have Cilium, BCC, BPF trays, all of these higher level projects that abstract this away. Cilium is doing what we call cloud native networking and security. Something like BCC or BPF trays are profiling, monitoring, performance benchmarking tools. So something similar as D-trace that some of you may know from Sun OS days. Then there is, for example, runtime security projects. There is seccomp in eBPF where you do system call filtering. This is how users will mostly experience eBPF. Another good example is if you're running Chrome, you will run eBPF to do isolation between Chrome plugins. Like Chrome plugins are sandboxed as well. Like a Chrome plugin, it's also just code that runs on your CPU. So if something needs to sandbox that, it's actually BPF doing syscall filtering there as well. But you're never seeing it as a Chrome user, but you're benefiting from the value of eBPF there.
Yeah, that's actually a really interesting use too that a lot of people forget about. They think of most of the network geeks think of this as just this thing running on a NIC and it's another way to offload processing. But there's these other interesting uses like you're saying.
Yeah, I think the most common one that people might not be aware of, if you're using an Android phone and you have ever looked at the traffic accounting statistics, how much network traffic your app is using, it's actually a BPF program doing that counting, right? It's completely unknown, like it's a hidden implementation detail as it should be. Right?
As it should be too. I mean, that's the thing, like it's transparent. The other thing that's interesting too is, I mean, if we're not on the phone, but if we're on again, back in a data center, yeah, if you blend BPF with the key value store, which is, parking the stats and whatever the telemetry you're getting, that not only makes it available later in a easily consumable format, but a scalable format too, which is it suddenly appears over there and over there and over there, and we can do post-processing, and all of the other, fun things you can do with that afterwards. That again is a really interesting thing because you're ungluing that from the kernel. Kernel is no longer really the bottleneck. It's just the orchestrator of the thing.
Yeah, there's one very key element to this, which I think is often a bit I think we have been looking at visibility systems that are extracting visibility from the kernel in a way that, there's going to be some kernel level component that will extract samples and they will be stored somewhere, and then you have some higher level system that will look at them and do something with this, right? And there is an overhead X accounted to how expensive is it to extract that, and the more network traffic or the more system load you have, the higher this overhead because you have more samples to extract. BPF changes this. Like, why do you have to assume that you need to export the visibility first and then act outside? Why are you not bringing the logic that you want? For example, give a concrete example. You want to know how many TCP connections have a latency higher than a certain latency number. Let's say you have compliance requirements, like you have a specific SLA. No TCP handshake should go beyond 20 milliseconds. You can do this by exposing or exporting TCP metrics for every connection and then checking in user space whether like any connections have exceeded that, or you can bake that filter.
But that's like the
TCP.
Sledgehammer approach, right?
Yeah,
I mean, that's the problem we've always had, like with IPFix and so on.
Exactly, yeah.
It was a fast path and a feature path, but it was it added at best a linear overhead to the processing, if not more. And this is just a thing that happens before somewhere else.
Yeah, or they would say, okay, like I just want to know statistically how bad it is, so you do sampling. So you look at only like 10% of the packets or something.
But counting it makes the whole thing worse, and Heisenberg, right?
Exactly.
You may have figured out a way to defeat Heisenberg.
With BPF, you can change this. You can encode the logic. You can say, I only want to notify my upper level system if a TCP connection took longer than 20 milliseconds. So if you only have 0.5% of your TCP connections violating this, you only pay.
It's more like an event-based thing.
Exactly.
Like only bother the 3 things that are interested, and the rest, forget about it. Right.
Exactly. Yes.
And that's the other way I look at it too. I mean, because I have implemented IPFix way back when, parts of it when I was at Cisco, and it was always this trade-off. Like, and then we got into the sample. There's always the sample derivative of the thing. Like, well, let's statistically dance around this, and it bumps into all of those problems, and this really cleanly solves the problem by saying just count what you want to count, and that's it. Simple,
Exactly. Yeah, this is
very appealing,
So I like to pound the table for the operator out there. So I think there's a bit of a conception at times that like eBPF is kind of reserved for these hyperscale. If you're running a global massive reverse proxy and you need to eke out every bit of performance counts, every bit of visibility counts, and everything can be kind of custom. What's the story out there for the average operator that's like, I'm kind of tired of IP tables, but we understand them. Am I simplifying my life by going to eBPF?
Yeah, I think there is, and the answer is probably maybe not by replacing IP tables. Maybe for some it is, for others it's not. I think eBPF brings much more to the table than replacing IP tables. I could show you amazing benchmarks on how if you run Cilium, your pod-to-pod between 2 nodes will be faster than if you do node-to-node for those same nodes, because we can bypass IP tables. Cool, like it's nice, but it won't, unless you're running in a high scale environment or the throughput is really important to you, it will not significantly change your life. But if I would show you as an operator a very fancy dashboard which shows you all DNS failure scenarios and which pod had how many DNS failures in the past, how many pods are currently experiencing DNS failures, how many TCP connection timeouts did you experience, like how many TCP sins were out there completely unanswered. As an operator, that gives you unique visibility that really changes your life. Like 9 out of 10 times, it's DNS, right? If there's an outage, you want to know if DNS is in play or out of play. If you have application logs and they just say, oh, I cannot connect to this or something, you want to know whether it's just a TCP connection timeout, whether it's a policy issue, and so on. This type of visibility, I think, is even more powerful than just let's replace IP tables, right?
Well, it's powerful too because you can introspect without impacting the traffic.
Exactly, yes.
And that's another, like Brent, like a simplification operationally. This is always a timing thing, right? So like if you go flip on features to start monitoring stuff, you might be too late, but you don't have the horsepower to leave them on all the time. And the other thing is it's the Heisenberg thing again. As you measure, you impact what you're measuring, and you screw up the measurements. And depending on how much, like we were saying, how much overhead you're adding. And this is, you could even, you can do mass surveillance of flows and things, and the overhead is really being handled by the NIC, which is interesting. And the packet flow carries on down the road. So to me, that's like vastly more simple for an operator to understand, like you're saying, especially with limited hardware. where you can't, a lot of solutions have a special NIC or a special, sort of a route processor light you got to stick into the box or whatever to do sort of co-processing and all of these other things. I mean, I've worked on a bunch of these. This is, again, like a bump in the wire, right?
Yeah, I think, although I don't want to drop what Brent was saying, because I think from an operational perspective, I mean, one of the things that we've seen is to take like an XTP program, for example. So you want to drop an XTP program in, and so you drop it into your network engineering organization, and they look at this and they go, oh, this is really cool. You show them the demo, they conceptually get it. Then when they start to try to understand it, they're like, wait, my normal tools I use to like look at packets on that host no longer work. And you're like, yeah, that's because the packets aren't going through that path. So there's, from an operational perspective, a lot of folks that are used to Linux networking being one way. I mean, it's just an educational thing, but I don't think you can discount that. And honestly, what we've seen is to have success. Either, yeah. No, I'm not. And I'm not saying you're discounting. I'm just saying, I didn't mean you, Tom. Maybe sometimes I do, but not this time.
Sometimes, not here.
But in general, I think to have success deploying these, I think that educational component and kind of bringing, the underlying networking engineers along is good. And Brent, I know that's usually where you focus, and you probably agree that you got to bring everyone around so they understand and feel a sense of ownership with it too.
Yeah, the thing I would argue like a lot of the stuff that Thomas worked on throughout his career was a lot of the tooling around Linux kernel, and so.
But what I'm saying is
usable because of that. Yeah.
There's no reason why you can't augment those tools like IP chains, etc., where you.
Oh, totally.
Yeah. You take again. If you stuff the output in a key value store back here, you can massage them so they show up in those classic tools that people are used to using.
Oh,
that
for
is
sure.
Important because there's automation around those things and all kinds of stuff.
Absolutely, and that's it. Like you have to look at the tools that operations team is used to using, right? So if you're using something like console, being able to put statistics into there, so they're used to going to console and they get, as an example, right? There's definitely it's important.
Yeah, don't let the glimmer of the new tech dissuade you from the sort of boring in quotes
absolute
nature of
worst thing ever
right?
is works on my laptop. That is a red flag for me.
Yep.
Well, the thing was what Brent was saying is actually incredibly key, right? I think it's any sort of significant shift in as much as I love about kind of the shift that eBPF is bringing to networking, and it will massively simplify some aspects. It will increase security in other aspects. It will build a new wave of building blocks that we will use to kind of shape the next age of networking. It has to come with the necessary familiarity to existing users, right? So yes, even though you can generate something truly cloud native with all like fancy new concepts, you still need to provide a traditional packet tap and like a PCAP output to connect to existing systems. But you can use powers of eBPF to make that smarter. So yeah, eBPF is a very powerful packet filter. So if you build a packet sync or a packet tap of some sort, you can use all of the filtering capabilities of eBPF and only get the relevant packets that you really want in your packet cap, for example. But then I think that's one side. But at the same time, you also want to provide a kind of a next-gen tooling set, which allows you to, for example, quickly and automatically troubleshoot the networking flow problem on the entire network. So if Cilium, for example, is running on both ends of a connection, so let's say it's a data center or cloud environment, two servers, Cilium is running on both of them, containers running on them, some connectivity is not happening correctly. BPF gives us all the different hook points. We can look right when the packet leaves the container. We can look at when the packet is leaving the actual virtual machine. We can check whether the packet is appearing on the virtual machine on the destination side, whether it's making it into the container. All of that can be automated, which is it's different, it's better, but it's maybe not the ideal first step for everybody. Some people might prefer to start out with let's say a TCP dump style kind of troubleshooting experience first and then make their way into something a bit more modern. So I think it's always about providing a journey and a story that makes sense and allows users to take new things step by step.
So Thomas, let's So how do you go from being a kernel developer for a decade to going to raise money in the valley and I think you're a really awesome story there, just because like I love the fact at how much time and effort you put into the work and kind of in becoming a leader in kernel in Linux kernel networking. You're synonymous with it, with the decade you put in at Red Hat. Kind of what spawned you, what kicked you off into going out and looking to raise money and start a company?
Yeah, it's a good question. We did not create Cilium to create a company. So the idea of Cilium was first, and it was a combination of it's logically the right next step. Like there's an obvious space to grow into. Like this is like when we started Cilium, Docker was just getting popular. Kubernetes did not really, it did exist, but it was not popular yet. We actually focused initially in the first year of Cilium, focused entirely on Docker, and then shifted over to Kubernetes. I think when we saw that the vision of how Cilium will change networking, that this has a chance in enterprise networking, the thought came up, maybe there's an opportunity around a company, because from a technical element, I've solved many challenges in my career, but I'm always also looking for new challenges. So going into a non-technical challenge was definitely appealing to me personally. So that this is where even the thought came up of creating a company of some sort. And then I think while working on Cilium, I by accident kind of reconnected with Dan Wendland, my co-founder, and he was definitely looking to start a company. So he was mainly looking for the technical aspect, and I think he came up with the same vision as me, but didn't have any open source project backing it up yet. So I think while doing his research, he found Cilium, and then kind of had a kind of an oh crap moment, like somebody else is doing this already. But then I kind of saw, oh, it's Thomas. I know Thomas. Maybe I should give him a call. So we chatted, and that's how we started the company. So there was not Cilium was not created because of the company. Cilium was created first, clearly kind of targeting a wider industry need that we saw as being obvious. And then it made a lot of sense to also kind of start a company around.
Oh, cool. It's fun to talk about how these different companies started. Everyone has a different story. Yeah, so we're kind of I don't know, time for a couple more questions and stuff. One of the things kind of carrying on with that is like where do you see the future with this going? Maybe both in terms of maybe your company, but also the technology itself. I mean, where do you see that heading?
Yeah, I think there's a ton of innovation that we will do on Cilium. I think Kyle in the beginning mentioned, I think the most important overall aspect, which is networking will move further up the stack. I think we are already seeing two extremes. We're seeing traditional hardware network providers trying to make a play in cloud native world. That's kind of the one side of the extreme. It's trying to bring the old world to the new world. Another side of the extreme is something like service mesh, where it's like the app, like I would say app teams or people used to deploying apps are trying to solve networking problems. Let's say, let's just deploy a bunch of apps.
We've talked about service mesh now, I think 3 times with 3 different guests. The observations are really consistent, like what you're just saying.
Yeah, and I think Cilium is right in the middle. I can actually do both. You can use Cilium you can even do, let's say, just run it on a hypervisor level as vSwitch. You can do VLANs if you want, if you really want to, and so on. But you can also implement, as I mentioned, we have an HTTP part, so you can actually do service mesh functionality as well. Like, I think bridging that gap, I think service mesh has a lot of great vision on what level networking should be. The actual data path implementation is clearly not ideal yet. But I think this is where eBPF and Cilium can come in and actually combine that vision, which is definitely shared with us, but provide a kind of an appropriate data path implementation for that.
Oh, that's super cool.
So sorry, go ahead, Dick.
No, that's all right. I was going to say I'm kind of interested in where you see eBPF as a technology and a community. Where do you see that going? And to add some color to that, when you explained, or when I first figured out what BPF was, I was like, why does anybody want to put anything in the kernel anymore? Like, you can literally write everything now in eBPF, so we could just do that and not be bound to modules, and then the kernel's going to end up a lot smaller. So I'm wondering if you're seeing any effects like that, or you've got any idea of what you think might happen in the future.
I think that's actually a great idea, or kind of quite great way to think about it, because it is realistic that a big portion of future kernel code will be written in eBPF. It is kind of I'm always surprised by the assumption a lot of people make that kernel developers will by default write bug-free code. Right? Like once it is in the kernel, it's bug-free, and it's definitely like it's secure. That's not the case at all, right? And any single typo has massive consequences on like billions of Linux-based devices out there. So the notion of adding another layer of protection, we haven't talked a lot about the eBPF verifier, which is kind of the cornerstone of the eBPF runtime. If you take that additional layer of protection and you can apply it to any kernel change, you're making the Linux kernel more secure. It's not just a programmability aspect, where you're actually making even a feature that would deserve to be native, you're making it more secure because you're creating a sandbox environment around it. And another element is that one of the most difficult aspects right now with the Linux kernel is that it's pretty hard to convince a server to be rebooted. What I mean by that is if you're running, let's say 20,000 Linux-based servers, and you have to zero patch something, how long do you think it will take you to do that? Because you can only reboot so many servers at the same time. It might take you a week. So you will be exposed to that 0 day for a full week. And there has been ideas around like live patching for a while. It's been around forever. Never really worked, right? And if you look at some of the key players contributing to eBPF, you will see that this is clearly one of the angles as well. I want to be able to hot patch my systems in a secure way. This is not networking specific in any way. This will apply to everything. But it's another great way you can, with eBPF, replace an entire kernel function and actually just hot patch it. Or that's also another use case that's a bit more networking specific. You can use eBPF to catch network packets that can, for example, exploit a remote 0 day, or like a particular crafted network packet. I mean, this any firewall can do, but with eBPF, you have one of the most efficient ways of doing this. This is, for example, what Facebook has been using on some of the previous 0 days triggerable by network. I think overall this is where eBPF is going. It will be step by step. So I would see that eBPF is becoming something very similar to what JavaScript is to a web browser, just a lot more efficient. But it will allow for massive innovation without requiring to change Linux code. And this is looking a little bit further ahead, eBPF is also an opportunity to bring operating systems closer together. If we look at Cilium currently being ported over to Windows, there's two ways to do this. You can either map Cilium high-level constructs to something that the Windows kernel already provides, which is what some of our competitive projects have been doing, or you can bring the eBPF runtime to a Windows kernel, and all of a sudden, a lot of other projects that exist on top of eBPF all of a sudden become portable again. Not something new, like not a new concept, but I think definitely another very powerful future direction of eBPF.
Yeah, awesome, thanks.
I look forward to eBPF on my ESX kernel at some point in the future as well.
And on your laptop.
Yeah, right. I mean, come on, it's got to be there. Yeah. No, that's really cool. That's really cool for sure.
Cool.
Yeah, Thomas. One other quick question I had was, so like, talk a little bit about, because you all, I know that you've got folks like Daniel working for you, I think, right, that have done a lot of the eBPF work in the kernel as well. So talk a little bit about, the work involved in managing a project where some of your work, you're enabling some of the functionality, and as you've added more socket functionality in the kernel, you've got patches landing there, you've got things in Cilium. I mean, the work spans a lot of things, and I've looked at some of the some of the pull requests and it's pretty amazing how you track all of this stuff. But talk a little bit about that, because I think you're in a unique position there.
Yeah, we in our company we currently have everything from low-level eBPF engineer to UI engineer using React, right? And basically everything in between. And we do a lot of things in parallel. I think what has been helping us as a company massively is to just adopt working open source principles. So we're not trying to reinvent the wheel in any way. We're not trying to bring, just because we're also a company right now, doesn't mean we're simply ditching our open source backgrounds. We're simply continuing as if we were working in an open source context. Open source projects are typically high scale, or I've always worked on large ones. So the concept of, or the problems of massive number of bug reports, users begging for features across the board is not something that's remote to us. We're just simply reusing existing concepts from that perspective. Also, the split between working upstream and making sure there is a balance between kind of working on the underlying foundation while also working on customer relevant features short term, all of that is not new as well, and we're trying to find the best balance there.
I love it. I love the open source angle to that. That makes a ton of sense. So
yeah, there's definitely, awesome. This is the one, I think, very, very new angle to me as now being also a company founder. Working upstream and working on the foundation, the element of fear that you also enable your competitors. I'm not very vulnerable to this in general, but I think it's still a bit new and it keeps you on the edge because you need to keep innovating the fastest. I strongly believe that in an open source infrastructure software world, what you need to go after is you need to have the best team possible and need to be faster and better at innovating, right? And you need to maintain that. But that's like it's not like you can invest a little bit and then it kind of pays off and you can monetize. It's a continued effort that you have to put into.
Oh, you're exactly right. I mean, that was my last gig. It was a race horse from day one, where you had to go, and we had people. We were competing against people like Cisco who had more resources, or and Ericsson and other folks. And you're right. It's a race to get the best people to build the best damn thing every day, which is hard. It's sort of like you've become a brain surgeon. You can't take a day off. You really have to hit it.
Yeah, I think it all comes down to having a fantastic team. Like Kyle mentioned, Daniel, we have a couple of other incredibly talented people. We saw the power of eBPF very early on. It was very obvious. So obviously the first thing we did as a company is make sure we hire all of the bright minds around eBPF to make sure they're working for us. And now we're maintaining a good culture and making sure we're successful as a company so we can keep everybody on. I think that's our strategy, and so far it has been working great. I think if you compare if we compete against a Cisco or somebody else out there, that's not super frightening to us because if you look at, we can work on an eBPF runtime feature on day one and then the next day work on a Cilium feature and actually just use that. Pretty much nobody out there is in the same.
Oh, your agility is your power. Yeah, exactly. It's David versus Goliath, but exactly. Goliath can run faster. Davey. Sorry.
Exactly. Yeah, that's why you do it. That's why you do a startup, right? That's the power. That's the uniqueness that you have.
Oh, that's fantastic.
The awesome side effect as well of building a company based on open source is that everything's open, right? And everybody feels connected to all of the projects that are going on because you can see all of the work that's happening across everywhere. And I think that also helps lean into that agility. You can have people that are very specialized on one thing, but then you've kind of got that fun chaos and innovation type of environment in open source, which I think is just awesome for startups.
Absolutely, yeah. It's also a challenge at the same time. If you bring in new people who have not done open source before, it can be a little bit frightening, right? It's a chaotic environment, lots of noise. There's 50 GitHub issues opened every day. You cannot even read all of them. How do you deal with that environment? I think some of you have been in a particular startup that have faced similar problems. That can be challenging, in particular to new folks. And fortunately, we have enough seasoned folks on that can kind of mentor and help find strategies to work around that.
You'll do fine.
It's like speaking in public for the first time, right? Or singing in public or something. People are like, I've got to let other people look at my code. This is weird. I don't want to do that.
No, you'll be fine. Hang in there. Hey, we're near the top of the hour, Thomas. So Do we have any?
Maybe throw out a plug on, so if somebody wants to get started on Cilium,
Yeah.
Where do they get started, and then like where, are there any open source tutorials you recommend? We'll link them in show notes.
Yeah, I think there's two great websites to get started. One is Cilium.io. That gives you everything from getting started guides. You can play with Cilium in a couple of minutes. There's tutorials on getting started with Minikube, getting your Minikube Kubernetes cluster going in a couple of minutes, and you can play with the network visibility. You can try out layer 7 policies, whatever you want. There's kind of tutorials for everything that your heart desires. And another one is if you are less interested in Cilium but are interested in eBPF, there is eBPF.io that we maintain. Again, lots of great intro-level content, tutorials, blog posts. There is also an amazing set of recordings from the eBPF summit that we held last year. For example, talks by Brendan Gregg and Liz Rice, intro-level talks, but also like deeper dive talks from some of the eBPF maintainers. I think that's a great way to get started. I think pretty much all the eBPF projects were covered in some way with an intro talk, so no matter what area has interested you, you will find a talk recording there of one of the projects.
Cool. Yeah, I popped those links in the chat there. We'll make sure we pop them up on the screen when we do that. Well, thank you for taking the time, Thomas. I know you, as you said, you're probably wicked busy chasing this down and making this work. So yeah, on behalf of everybody here at the Net, thank you for joining us, and hopefully we could have you on again in the future if you have some time later on this year.
Awesome. This has been great. Thanks a lot for having me.